Oh, because you didn't have it. What's up, math scholars? Thanks for joining us for the second half of the study guide. Actually, the majority of the study guide, number 4 through the end. Test is coming tomorrow. Half's on Polaris, half is on paper. So bring your Chromebooks, have them charged. Bring your calculators, have them charged if they can charge. And yeah, who's excited for our test? Who's excited? It's homecoming this weekend. We are not excited about anything. Who's excited? It's Friday tomorrow. All right. Well, anyways, let's go ahead and do some quadratic formula. Maybe I can wake them up by having them sing something. All right, raise your hand if you can give me A, B, and C. And then we're all going to sing together. A, B, and C. Logan, what's A, B, and C?
4.
Good. Good. Okay. All right, and since you're all asleep but we need to wake up, let's all sing. Ready? You gotta sing slow, though, so I can write the numbers in. And a 1, and a 2. X equals the opposite of B, plus or minus the square root of B squared minus 4AC, all divided by 2 times A. All right, we actually did pretty good singing. I'm going to go ahead and type in this stuff first in the green circle. Can anybody tell me what that stuff is called in the green circle? Discriminant! A decombinator. That's interesting, but it's called the discriminant. So that ends up being 48. It is very, very important you put that -8 in parentheses. That 2 times 4 on the bottom will be 8. Is 48 a perfect square? That's when you go, darn it. On the test, that number, your discriminant, will be a perfect square. So go ahead and tell you that now. It'll make it easier than this problem is. But I oftentimes make the study guide harder than the actual test to over-prepare you. Let's go ahead and break that 48 down. Simplify it a little bit. It's 16 times 3, and 16 is 4 times 4. So radical 48 can actually be simplified into 4 radical 3. So 4 radical 3. And then if you don't want to be a math scholar, you would stop here. But if you do want to be a math scholar, you can simplify that a little bit. 8 can be divided by 8, and that will be a 1. And then 4 can be divided by 8. Think hard. What is 4 divided by 8? 0.5, or 1/2, right? So to write it as 1/2, I put 1 on the top, 2 on the bottom, but that radical 3 has to go on the top. And rather than write 1 radical 3, I'm just going to write it radical 3. This is the most scholarly way of writing it. Well, on the test, we won't have this issue because this will be a perfect square. So you guys want to play pretend with me real quick and we'll pretend that was a perfect square? Okay. Once this is done, I'll get a new slide and we'll play a little pretend. That's what we did in my other classes yesterday. So you're all caught up and ready? Play pretend? Okay, so here goes. We're playing pretend. We're going to pretend it was 8 plus or minus radical 49 over 8. So at this point, you're like, hot dog, that's a perfect square. What's the square root of 49? 7. That makes our life very easy to finish this problem off. What is 8 plus 7? 15. So you're going to want to do 15 divided by 8 for your first answer. And you can do a decimal if you'd like. And then what is 8 minus 7? 1 over 8 is your other answer. Just make sure you're clicking enter before you're dividing. That's where people mess up. They type in 8 plus 7 divided by 8. You have to click enter before you divide. Make sense? All right. So that was our fun pretend session. Now we're on number 6. All right, we're going to need to use a discriminant. Who remembers what a discriminant? No, sorry, a conjugate. Oh, too many big math words this morning. So that's number 6. Number 5, now that you say that, is lost at the bottom of number 3. There it is. It got lost then. All right, thank you. Yesterday, I was walking around looking at a bunch of different groups working, and people were foiling this. Is this a foiling problem? It is not, because it's a plus problem. See that little plus right there? So it's just a plus problem. So we just add our like terms. So add your 2 pink numbers together. 6 and -5 is 1. Add your 2 green numbers together. -3 and 10 is 7. That's all you have to do. That number 5 was actually a piece of cake. All right, we're on 6. I'll try to use my right terminology. We need a conjugate. What's a conjugate? It means opposite. So we're going to need to look at this denominator. We're going to need to group it, put parentheses around it. We're going to need to put a conjugate right here and a conjugate right here. All right, so what is that conjugate going to be? 2 plus 5i, very good. So on the bottom, it's 2 plus 5i, and on the top, it's 2 plus 5i. All right, on the top. All right, this top part, these two are not conjugates, so you're going to do a full-out, full-fledged FOIL, all 4 rainbows. So 6 times 2, 12. 6 times 5i, 30i. 2 times I, 2i. And 5i times I, careful with this term, 5i squared. Now, whoop, 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 there's an alarm going off. Why is that alarm going off? Yeah, anytime you see an I squared in any imaginary problem, you want to replace it with a -1 immediately to gateway back into the real world, the real number world. So I scribble out this I squared, I replace it with a -1, and then I think to myself, what is 5 times -1? Positive 5 times -1. -5. So this is actually a -5 up here. All right, on the bottom, the 2 on the bottom are conjugates, so you just have to do the first matchup, 2 times 2, get 4, and do the last matchup. -5i and positive 5i is -25i squared. Whoop, 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 there's an alarm going off. What is that? Replace this I squared with a -1, and then think to yourself, what is -25 times -1? Positive 25. And then we're going to clean it up a little bit. On the top, we have some like terms we can combine. The 12 and the -5 is 7, and the 30 and the 2 is 32i. And then on the bottom, it's just a 29. Now, this is a multiple choice problem tomorrow. Do you think any of the choices will look like this? No way, Jose. So let's talk about how the choices will appear. The choices will actually separate the real part of the answer from the imaginary part of the answer. The real part of the answer is 7 over 29, and the imaginary part of the answer is 32 over 29i. So take a real quick look at how they got from what I have in the green circle to what I have in the pink circle. Make sure you kind of understand what they did. All right, so I did print out a formula sheet to hand to each and every one of you tomorrow, and the discriminant is not clearly labeled on the formula sheet, but if you're savvy enough, you'll know it's hiding right here in the quadratic formula. So you have to know that the discriminant is the b squared minus 4a part of the quadratic formula. It does not include the square root. Okay. All right, so b squared is -11 squared minus 4ac. If you type that L in, I believe you get 73. So just make sure you're using those parentheses. All right, it does say how many solutions would there be if we had that positive 73 as our discriminant. What did you guys put? 2 real solutions. Let's just recap what else could happen tomorrow. If your discriminant ends up being a negative number, what does that tell us about our solutions? Well, the 2 imaginaries. And think about that. If you get a negative discriminant, like -16, and you have to square root it, it's going to give you an imaginary answer. Okay? So just kind of think through it. And then, what if you would get a discriminant that would end up equal to 0? What would that tell you about your solution? Only one real solution. Yeah, because you would just get a 0, and then you'd have a plus or minus 0. One real solution. Those are the other possibilities of what could happen. All right, number 8 is next. So there's our foiling problem. Now, are these 2 conjugates? No. So, Aaron, we got to do full-out foil. They're not conjugates of one another. So 4 rainbows, everybody. Rainbow number 1 would be 10. Rainbow number 2, -25i. Rainbow number 3, a 16i, I think. And rainbow number 4, -40i squared. Whoop, whoop, whoop. Why's that alarm going off? Yeah, you never ever want an I squared to be your final answer. So you scribble it out, you put a -1 in its place, and you think, what is -40 times -1? Positive 40. And then we want to clean it up for our final answer. Add up your real numbers, the 10 and the 40, that's 50. And then add up your imaginary numbers. Negative 25 and 16. Is that negative 9i? Yeah. All right, we have ourselves a little word problem. This should be fun. Now, I do have a typo in this word problem. I need you guys to make this t right here an x, so it makes sense. Right there. A rock is thrown from the top of a tall building. The distance in feet between the rock and the ground, x seconds after being thrown, is given by y equals negative 16 x squared minus 2x plus 733. How long after the rock thrown is it 200 feet above the ground? Now, 9 times out of 10 with word problems, it's all about a decision you have to make. And you have to decide, is this 200 going in for x, or is this 200 going in for y? What do you guys think? It's going in for y, because x is time, and 200 is distance, height. So let's put the 200 in for y, and then we're going to solve it using our quadratic formula. All right, so to do our quadratic formula, the key is you have to be set equal to 0 first. So see that 200? It can't be here. So let's subtract the 200 over to join that 733, and then we'll be quadratic formula ready. It'll be 533 once it's in there. All right, so A is negative 16, B negative 2, and C 533. All right, and a 1 and a 2. X equals the opposite of B plus or minus the square root of B squared minus 4AC. These numbers are big. It takes me a while. All divided by 2 times A. All right, the numbers are a little big, but I'm pretty sure we'll survive. Go ahead and figure out the discriminant for me, right here. That stuff. Okay. All right, hello, video people. We forgot about you. Our discriminant was 34,116. We went ahead and found the square root of that and got 184.71. All divided by negative 32. And now we got to finish the problem. So we got to do it twice. Once with the plus and one with the minus. So when I do it with the plus, here's what I type in. 2 plus 184.71. Enter. Divide by negative 32. So my first answer is negative 5.83 seconds. Does that answer make sense? No, the rock will not reach that altitude of 200, negative 5.83 seconds after being thrown. So you trash can that answer. Let's find the other answer. 2 minus 184.71 divided by negative 32. 5.71 seconds. That's our answer we want. So it was a word problem and it had really large numbers, but all in all, it was just quadratic formula. So I don't think it should have been that problematic. All right, we've arrived at number 10. Is it a FOILing problem? No, it's a subtraction problem. When you have that subtraction sign will distribute in. I don't know if I can write on my smartboard that high accurately, so I'll move it down. But that negative sign will distribute to the 8, making it a negative 8. And the negative will distribute to the 2i, making it a negative 2i. But really, at that point, all you have to do is add up your like terms. So I'm going to add up my red real numbers. 7 and negative 8 is negative 1. And I'm going to add up my blue imaginary numbers. Negative 3i and negative 2i is negative 5i. And you're done. That's a multiple choice problem if you're wondering. For sure. What we on now are graphing problems, so we're almost done. If you haven't dug your calculator on that book bag, dig it out for our graphing problems. You can do all those in the calculator. Alright, hello people in the video. So we went in our graph world. We typed in x squared minus 4x plus 2. And we kind of discussed that we're going to draw our boundary line with a solid line. You use solid lines anytime you have a greater than or equal to, or a less than or equal to. But then they told me that we're going to need to shade above. So what we selected is what I call the shade above wedge. It looks like this little guy. And then we're ready to hit graph. Or okay, and then graph. Okay. And then graph. So it looks like that vertex is probably at, and you can probably tell by maybe looking at your table. Let's see if we can figure out which one's our vertex is by looking at the table. Your vertex would be 2, -2, because you can see the symmetry comes in 2, 2, -1, -1, 2, -2. So 2, -2 is your vertex. And then it kind of, back to our graph, it kind of opens up and it's shaded up above. We use a solid line for a boundary line. And that's it. Pretty easy. All right, we're about to graph 2 at one time, but we're going to discuss where the shading is going to happen and whether the lines are solid and dotted and all that jazz. So let's talk about equation 1. Would I use a solid or dotted line for my boundary line for my actual parabola? Dotted. And then would this be shaded up above or down below? Above, because I would read it to you, y is greater than x squared. Okay, greater than is above. What about this one? Dotted or solid line? Okay, so both can be dotted. And then shaded up above or shaded down below? Down below, because I would read it to the class, y is less than, blah, blah, blah. All right, let's type it all in. I'll pause the video while I go do the typing. All right, we've got everything typed in. You can go ahead and look at my calculator and compare what you've got typed. Make sure you have a shade above wedge for your first line, shade below wedge for the second line. And just a reminder, your solution region is where both of the shadings overlap one another. There's my blue. There's my red. So there's a really, really tiny sliver right in here. It's almost like a little fish shape or a football shape where they're overlapping. So we're doing a fast job to draw that. Now, if you're wondering about the drawing yesterday, or tomorrow, how accurate does my drawing have to be? This is actually a multiple choice problem. You would select the one that had the correct graph or the correct system that goes with the graph. Try my best. I'll try my best at drawing. I'm terrible at drawing. So dotted line, shade it up, and then dotted line, shade it down, and my solution region I'll do in the third color black. It'll be right in here with that dotted line boundary. Hey, thanks for joining us for our video. Hopefully you're good to go on the test, and if you're not, we'll see you at a study party.